Hey guys, so in this video we're going to be talking about vitamin D deficiency and how that relates to coagulation factors and the use of the drug warfarin. So starting off, how is vitamin K made? So remember that your liver has an enzyme. This is the shape of a liver. It has an enzyme called epoxidase. Epoxide reductase. This is what converts vitamin B to its active form. So this is what converts vitamin B to active form. This is what converts vitamin K to its active form. So now active vitamin K is very important for coagulation factors. So to illustrate this a little bit clearly, let's say that this is a platelet right here. Here's another platelet. Each of those platelets have, I'm just drawing this man here, but this is your coagulation factor. The coagulation factor need to have a negative charge. And that negative charge, as you know, having calcium is one of the requirements for coagulation cascade. So this calcium has to bind this, and this is how the platelets aggregate. Platelet aggregation. So if you don't have vitamin K, you don't have this negative charge, which is a carboxylation of the coagulation factor. This is the alpha carboxylation of the coagulation factor. If you don't have vitamin K, this is done by vitamin K. Vitamin K. Right here. So this is why, I remember one of the things that you need for thrombosis to occur is that you need to have in order for platelets to aggregate, for secondary hemostasis to occur, you also need phospholipid, which is done by which is given by the surface of the platelets. You need calcium, which comes from those granules, the dense granules of the platelet. You need so this is how it is. This is what calcium does. Now, which factors are activated by calcium? So that's looking at our map here. Calcium-dependent factors are 2, 10, 9, 8, and protein C and protein S. So let's write them down right here. These factors are 2, factor 10, 9, 8, protein C, and protein S. These are all calcium-dependent. Now, what happens in warfarin is that warfarin ends up decreasing C and S way more because they have a shorter half-life. And just to remind you, protein C and protein S, their job, I really encourage you to watch this other video that I have on the same playlist about these coagulation factors. So protein C and protein S, their job is to inhibit factor 8 and factor 5. Remember, factor 8 and factor 5 are cofactors that ultimately lead to activation of factor 10 right here. So if you don't have protein C and protein S because they have a shorter life, they get degraded easily and there's no vitamin K, you're going to end up with a lot of these factors. So this is what causes coagulation in the initial state of warfarin therapy, and you get this you get the increased risk of thrombosis. So I hope this makes this a little bit clear. I wish you all the best, and please leave a comment if this was helpful.